The commercial fishing industry represents a complex, multi-layered operation that bridges the harsh, unpredictable environment of the open sea with highly structured industrial processing facilities on land. A dynamic workflow captured perfectly across the provided visual references. The journey begins on the deck of a massive fishing vessel, where maritime crew members engage in the physically demanding task of managing heavy tactical gear. In image 10.8, we see the crew working on the wet deck of a trawler, carefully hoisting a large, heavy-duty blue and brown fishing net up from the sea. This critical phase requires precise coordination among the deckhands, who wear bright orange waterproof safety suits and protective helmets to shield themselves from the elements and heavy machinery. A scene that underscores the raw manual labor and inherent dangers of deep-sea harvesting, while the crew manages the physical deployment and retrieval of the nets on deck. The entire operation is guided by advanced technological systems situated in the vessel's command center. This technological oversight is illustrated in image 10.5, which shows the captain's bridge or control station filled with multiple illuminated electronic monitors, navigation screens, and sonar displays. A crew member sits at this console, monitoring real-time data, seafloor topography, and fish school tracking metrics that dictate exactly where and when the nets should be dropped, demonstrating how modern commercial fishing relies as much on digital precision and maritime telemetry as it does on physical strength beneath the surface of the water. The direct result of this technological targeting takes place inside the specialized gear, as shown in image 10.3. The perspective shifts underwater to look directly through the wide mouth of a submerged fishing net, where the mesh stretches out against the bright blue ocean water as fish are funneled deep into the collection pocket, capturing the silent, efficient mechanism of industrial harvesting before the catch is hauled back to the surface. Once the net is fully loaded and pulled back onto the vessel, the crew must manage the immense volume of the harvest on deck. In image 10, we see the massive haul of fish spilled into a large holding bay on the ship's deck, where deckhands in heavy winterized gear and bright orange gloves use long tools to sort, manage, and secure the shifting mounds of fresh fish amidst the rolling waves, marking the transition from active harvesting to onboard preservation. Once the vessel returns to port, the seafood is transferred directly into automated industrial processing plants designed to handle high volumes with maximum maximum efficiency and hygiene. This processing phase is clearly visible in image 10/3, where an operator dressed in a bright orange waterproof industrial suit stands along an automated conveyor belt system, overseeing a continuous stream of silver fish. As they move rapidly through sorting and cleaning machinery, illustrating the highly organized assembly line nature of modern food production. The sheer scale of this processing operation is further emphasized in image 10/88. Which highlights a massive metal sorting bin filled to the brim with thousands of small, fresh fish that are being meticulously inspected and distributed by workers wearing protective gloves, ensuring that only quality catch moves forward through the supply chain. Finally, the processing workflow involves precise manual preparation for specific seafood varieties. In image 10/80, a worker wearing an orange protective apron and heavy-duty red rubber gloves is shown using a sharp filleting knife to clean and slice fresh flatfish on a specialized cutting station, demonstrating the technical skill required to portion and prepare the seafood for packaging, distribution, and ultimate consumer consumption, completing a seamless industrial cycle from ocean to table. This intricate progression from the untamed marine environment to the meticulously controlled production floor highlights the interdependence of human labor, mechanical automation, and advanced navigation logistics that define contemporary aquaculture and commercial fishing. Beyond on the initial filleting and portioning stages shown in image 10/80. The processed seafood enters an ultra-fast flash freezing and preservation phase designed to lock in peak nutritional value and freshness, utilizing liquid nitrogen freezers or blast chilling tunnels that drop temperatures rapidly to prevent cellular breakdown in the fish tissue. Simultaneously, quality assurance technicians conduct rigorous batch testing for safety compliance, monitoring factors such as temperature, consistency, levels, and trace elements to meet international food safety standards before the product is cleared for global shipping. The logistical chain then shifts to automated packaging systems where the fillets and whole fish are vacuum sealed in heavy-duty puncher resistant polymers, packed into insulated master cartons with dry ice, and loaded into refrigerated shipping containers destined for international distribution centers. This entire operation, heavily reliant and on real-time data tracking from the vessel's initial digital coordinates captured in image 10.5e. Due to the automated tracking barcodes applied at the final packing station, demonstrates how modern technology has transformed a traditional subsistence practice into a highly optimized, high-throughput global supply chain. As global demand for marine protein continues to rise, these facilities increasingly incorporate sustainable tracing mechanisms, allowing consumers to scan a retail package and trace their specific fish back to the exact vessel, ocean quadrant, and harvest date documented during the deck operations seen in image 10C and image 10. Ultimately, the seamless coordination between the deep-sea maritime crews braving volatile oceanic conditions and the land-based industrial processing teams working along highly efficient conveyor lines ensures that premium seafood can be safely, sustainably, and reliably delivered to markets, restaurants, and dinner tables around the world, exemplifying the pinnacle of modern industrial food engineering. The integration of these maritime and industrial processes requires an unprecedented level of structural synchronization, where every single link in the operational chain must function with flawless continuity to prevent any disruption in the delicate cold chain that preserves the integrity of the harvest. As the seafood moves from the manual processing tables, the underlying infrastructure of the facility utilizes specialized waste management and byproduct recovery systems to ensure that no part of the marine resource is squandered, transforming leftover frames, skins, and viscera into high-value fish oils, marine collagen, and nutrient-rich animal feeds. This secondary processing loop operates parallel to the primary production line, embodying the principles of a circular economy within the modern industrial seafood sector. Inside the main processing zones, advanced computer vision systems equipped with multispectral imaging cameras scan each fillet moving along the fast-paced conveyor belts to automatically detect and reject any pieces with structural defects, bruising, or residual bones, achieving a level of quality control that far surpasses traditional manual inspection methods. These automated sorting mechanisms utilize high-speed pneumatic sorters that gently deflect approved products into specific channels based on precise weight thresholds, optimizing batch portions for commercial wholesale distribution. Meanwhile, the engineering teams within the facility constantly monitor the environmental parameters of the processing floor, regulating ambient air temperatures, humidity levels, and airflow patterns to mitigate any risk of airborne contamination and maintain a pristine sterile environment. The deep-sea harvesting phase, as visualized during the intense deck operations where heavy units are broad-bored under volatile maritime conditions, serves as the critical catalyst for this entire land-based industrial complex, meaning that any delay in the vessel's transit or any malfunction in its onboard refrigeration systems could jeopardize the entire subsequent workflow. To counter these oceanic unpredictabilities, modern commercial fishing fleets are increasingly utilizing satellite-linked predictive analytics that synthesize historical catch data, current meteorological patterns, and real-time sea surface temperature anomalies to optimize transit routes and minimize fuel consumption, allowing vessels to navigate directly to the most productive fishing grounds with surgical precision. This mathematical optimization of maritime logistics not only reduces the carbon footprint of the fishing vessels but also ensures a highly predictable and steady influx of raw materials for the land-based processing infrastructure, stabilizing market supplies, and enhancing food security. Once the optimized transport vessels dock at the industrial port facilities, high-capacity vacuum pumps and specialized crane systems unload the chilled catches directly into seal temperature controlled receiving bays, completely eliminating exposure to external ambient heat and environmental contaminants during the critical ship-to-shore transfer phase. From these receiving bays, the fish are instantly transitioned onto the initial washing and scaling lines, where automated rotating drums and high-pressure water jets remove external debris and superficial scales without damaging the delicate underlying flesh. The continuous flow of product then feeds directly into the primary cutting stations, where the industrial workers, whose specialized manual techniques are highlighted in the precise handling of individual specimens, execute clean, uniform incision that maximize yield per fish, and prepare the raw material for the automated filleting machinery. Every single piece of equipment within this processing sequence, from the stainless steel cutting surfaces to the modular plastic conveyor belts, is engineered specifically for rapid and thorough sanitization, allowing the facility to execute comprehensive clean-in-place procedures between operations. Shifts to eliminate any biofilm accumulation. The rigorous sanitization protocols extend to the worker uniforms, boots, and protective gear, which must undergo automated chemical scrubbing and of sterilization before any employee enters the high-care production zone. The technological sophistication of this entire ecosystem reflects a broader shift toward total digitalization within the global food supply chain. Where the history of every single consumer package can be traced back through an immutable digital ledger to the exact geographic coordinates where the net was deployed in the open ocean. This absolute transparency not only builds consumer trust, but also acts as a powerful deterrent against illegal, unreported, and unregulated fishing practices, forcing the global industry toward higher standards of ecological accountability and ethical labor practices. As the packed and sealed containers are finally transferred into the massive automated storage and retrieval systems of the deep freeze distribution centers, the logistical software coordinates with global shipping networks to optimize the final distribution phases. Ensuring that the seafood reaches its ultimate destination in pristine condition. The harmonious interplay between human expertise on the open seas and mechanical precision within the land-based plants underscores the incredible technological advancements that define modern commercial fishing, proving that the preservation of quality requires an unbroken, highly sophisticated continuum stretching across oceans and continents. The profound transformation of the global seafood industry relies heavily on this digital and mechanical orchestration, where the continuous flow of data guarantees that every variable within the cold chain is monitored with meticulous oversight from the moment the fish leaves its natural habitat. Within the high-efficiency freezing tunnels that follow the initial packaging phase, advanced cryogenics play a pivotal role, utilizing precise injections of liquid nitrogen to lower the internal core temperature of the packaged fillets to exactly 30 degrees below zero within mere minutes. This rapid thermal reduction prevents the formation of large ice crystals within the cellular walls of the fish tissue, effectively eliminating the risk of drip loss during the eventual thawing process. And preserving the delicate texture, natural moisture, and rich nutrient profile of the protein as if it had been freshly harvested that very hour. As these frozen units exit the chilling chambers, they are immediately funneled through automatic check weighing systems that verify the exact mass of each package down to the tenth of a gram, instantly communicating this data to a centralized logistical network that adjusts inventory records in real time. Packaged goods are then systematically sorted by specialized robotic arms that stack the cartons onto heavy-duty pallets with geometric precision, optimizing the structural integrity of the cargo for long-distance maritime or overland transport. These pallets are wrapped in multiple layers of thermal, moisture-resistant film and fitted with active radio frequency identification tags, which continuously broadcast temperature, location, and humidity metrics to supply chain managers worldwide via satellite networks. This ensures that any unauthorized temperature fluctuation during international transit triggers an immediate automated alert, allowing logistical teams to intervene before the product's shelf life is compromised. Concurrently, the water filtration and treatment systems within the land-based processing facilities work tirelessly to recycle millions of gallons of operational water through multi-stage reverse osmosis and ultraviolet disinfection loops, minimizing the environmental footprint of the plant and adhering to the strictest sustainable manufacturing guidelines. The internal laboratory teams conduct continuous biochemical analysis on random samples from every production lot, utilizing high-performance liquid chromatography to verify the absence of heavy metals, environmental toxins, or synthetic residue, thereby guaranteeing a product of absolute purity for health-conscious global markets. On the vessels themselves, engineering advancements have led to the implementation of automated catch handling systems below deck, where fish are instantly transferred from the main collection bays into chilled seawater tanks maintained at an exact temperature of 1 degree Celsius, minimizing stress-induced lactic acid accumulation in the fish and significantly elevating the baseline quality of the raw material before it ever reaches the processing plant. The seamless integration of these maritime and land-based systems illustrates how modern food science has elevated commercial fishing far beyond its historical roots, turning a volatile and dangerous trade into a highly predictable, sustainable, and mathematically optimized industry that feeds millions daily. This global silhouette of technology ensures that whether a consumer purchases a fillet in a landlocked metropolitan supermarket or at a high-end coastal restaurant, the product represents the pinnacle of safety, freshness, and ecological responsibility, made possible by an unbroken chain of human dedication and mechanical excellence stretching across the world's oceans. The maintenance of this high-tech supply chain demands that the operational environments, both at sea and on land, adapt continuously to the evolving strictures of the modern global marketplace. On board the fishing vessels, as documented during the retrieval operations in Image 10 the harsh reality of dealing with shifting ocean currents means that the ship's stabilizing systems must work in tandem with the deck machinery to ensure that the heavy nets do not swing dangerously during extraction. This physical volatility is countered by the predictive stabilization algorithms managed